Hi there, everyone. Welcome to ServerlessDays Bhubaneswar. So this is the first event of ServerlessDays Bhubaneswar of this year, and it's on using serverless and full stack development. So all of us are, stuck in this pandemic, so all the events are virtual, so we cannot afford to actually go offline and have a physical event. But we are having many speakers coming on board thanks to this pandemic. So let's welcome the speaker for the session, Eric Johnson.
Hello, Eric. Hi, how are you?
I'm doing good, Eric. How about you?
I am great. I think I was telling you earlier, just so you know, it's very early where I'm at. So I've already got a Diet Dr. Pepper in me, so that's good. So I'm pretty amped up, and I'm pretty excited to be doing this.
That's great. We are also excited to have you on board. So let's get started. The screen is all yours for the taking, Eric.
All right, real quick before you take off, I can't see if there's any questions the way we've got set this up. So feel free to pop in, and if there's any questions that I need to answer at the end, I'm going to let you moderate that. Is that cool?
Perfect. I can show it at the end of the session. We can have a 5 minutes block for the Q&A, or do you want to show it during the session itself?
It's up to you. You can jump in. I'm pretty casual. I'm pretty relaxed. So if you were to jump in and go, Eric, we have a question, I'd be like, all right, let's do the questions. So no problem. Now, I do want to say, okay, I've been working on this, and you taught me how to say it. So it's Bhubaneswar.
That's right. Yeah, yes. You got it right.
Okay. I didn't. I think you're being nice, but okay, we'll take it. So
100% for the effort, Eric. So the screen is all yours. Let's get started.
Thank you. All right. Well, I am excited to be here. Thrilled to be here. Anytime I get a chance to speak, anytime I get a chance to talk about serverless, I love it. And so I'm thrilled, and I appreciate y'all asking me to be here. This session, just to kind of give you a heads up, this session is really, this is I don't know what this serverless thing is. So that's where we're coming from. And this may seem, if you're watching this, you go, Eric, I've been doing serverless for a while. This is, I get all this. I already know all this. And that's okay. But surprisingly, a lot of people don't. They look at this and go, I just don't, serverless is baffling to me. And so I don't understand. So my goal today is to kind of explain, if you're a full stack developer and you work with full architecture, front end, back end, things like that, how does serverless apply? What does it mean to put in serverless? So that's kind of what today is all about. All right, let's get started. So first of all, let me tell you a little bit about who I am. That is me. It doesn't get any prettier. I'm sorry. It's just, that's me. My wife married me because I'm funny, not pretty. So there you go. I am EDJ Geek on Twitter. You can find me there. I do try to answer questions. So hit me up. I can't answer them all, but I try the best I can. I'm a husband of one and a father of 5. That's right. I have 5 kids. It's crazy. This house is hopping. You'll probably see one run behind me at some point. I'm a senior developer advocate for serverless at AWS. I've been there for over 2 years now, but I've been doing serverless since the day it came out. I remember the day they announced serverless at AWS. And I looked at it and went, why would I do it any other way? That just makes sense to me. So I've been a solutions and software architect for over 25 years. I'm an old guy. I'm a music lover. I was a drummer. I thought I was going to be a professional drummer. Turns out I'm a really good drummer for one finger, but I'm fairly average in real life. So that didn't work out. I'm a pizza lover. You've heard, if you follow me at all on Twitter, you see I fight tooth and nail on there should be no pineapple on pizza. So, and I'm a pusher of serverless for everyone. And that means I think serverless could work for almost any architecture, and we should make it, we're trying to make it available and help anybody understand it. So most of my shirts say, I don't know if you can see, it says serverless for everyone right here. I drew this. My girls think it's a high school locker. It's not, but there you go. All right. So a couple of things, a couple of rules when I'm talking to help you. Rules aren't the right answer, and this is kind of one way. I can't see your feedback, but I will hold up my hand. This is any number I want it to be. Hopefully that helps you. I was born this way. I'm comfortable this way. I make one-finger jokes, and I'm comfortable with that. If that makes you uncomfortable, I'm comfortable with that too. So we're going to have a good time. I'm going to be fine either way. I do this. These are quotes, not apostrophes. I'll say this a lot, and I do this for thumbs. So that'll help you when I do, especially I do this a lot. I have 5 kids. You're like, that's a 1. So hopefully that helps you. All right, I'm going to stop yammering. Let's get into this. So when we think about the application journey, when we're, all right, I've got an application. Probably most of us started here, right? Where we're learning to develop, and we've got one machine, and it's going to have, it'll have your proxy or firewall on it. It has your server on it. It's your code is on it, your database is on it, and it's probably, for me, in my mom's closet, or depending on where else you may have it. And this is a very common way that we get started, right? And so when moving on a little further, and if this doesn't look familiar to you, then you started pretty recent, because this, it's not too long ago. It was a single server that did everything, or you start breaking it out, Now, as your application starts to grow, then you go, you know what, we're going to create a tiered architecture. We're going to break these apart, right? And maybe we even get crazy and we separate our client and our backend, so that we have one server handling firewall, one is our client, the next is our backend, the next is our database. But the problem with this is if one of these goes down, the entire site is down, right? So if my client drops, I'm done. My backend drops, my database. So it's not a resilient or architecture. So to build in resiliency, we add redundancy, right? So the redundant tiered architecture is this idea of using a proxy or firewall. And this isn't even completely redundant. Actually, we would probably have an active passive firewall on this, right? Or an active or passive, so that was two machines handling this. And then we've got our client load balancer, and our client load balancer points to our clients, And then the client can call to the backend through a load balancer, and that's separated. And then the backend talks to the database. And you can see in here with this redundancy that now, if one of these goes down, if let's say the left side, we'll call it server 1 or server 7, if that goes down, then we still route to the other one. So we have some resiliency to our site. It's more reliable. It's not as reliable as millions of servers, but it's more reliable than one server for each tier. But hopefully, if you're building this production website, hopefully it's exploding on you and you're getting lots of traffic, and you go, you know what? I need a more redundant architecture. Well, here's what that looks like. And if you've been doing this for a while, and I've been in the room where we had hundreds of servers, right? So you still got this firewall. I still have a single firewall. I really need to update this. So you got these firewalls, and then they're pointing to your client load balancer. And then you have, I don't know how many servers here, 10, 11 servers handling your client. So it rotates. Okay, and then you've got these firewalls, these load balancers that are pointed to your back end. And again, you can spread that load across those, and then you're spreading the load across databases, right? And databases are a little harder because you got to deal with this syncing the data, backups, different things like that. So this gets you to this place where you go, you know what? My architecture is more redundant, right? But here's the deal with that. More redundancy introduces more infrastructure, which introduces more management, which introduces more cost. So when we look at this architecture, we're saying, okay, I've got these 12 servers, but now when I update my application, I make a change to my code, I'm doing some multivariate testing, I want to test some different things, I have to push those code changes to every single server. And we've seen these. I mean, we do this in the cloud. We've seen this architecture where we'll say, okay, we'll roll it out to 2 servers, and now it's out to 4 servers, and now it's out to 6 servers, or maybe we roll it out to 10 new servers, and then we do, a blue-green or a black-red, or there's all kinds of different patterns for deploying architecture. I remember I worked for a company, and this is years ago, but we had an architecture just like this. We ran our own data center and our own office. And when it was time to deploy the application, we deployed every 2 weeks. And it was an all-night thing. We went in on a Thursday evening. I say we. I didn't actually. I was part of this. I'm grateful for it. But our operations team went in on a Thursday night, and then it went all night because it never went right the first time. And I remember getting the call like 3 a.m. Hey, this code's broken. Or, hey, this isn't working. There's a lot that has to happen here, right? So you have a lot more, and again, with more machines, there's more cost, right? So this idea of using actual physical machines, either in your own architecture, or I'm sorry, your own data center, or renting space or something like that. Now you've got to manage the hardware, right? You've got to patch it. You've got to upgrade it. You've got to replace stuff as they go bad. And when you need a new server, and it used to be, hey, okay, we're running 5 servers, it's not carrying it, let's order 3 more, right? So we order 3 more. They take the several weeks to get to the office. Then we have to build it out. We have to provision it. We have to patch it. And if you're me, you did it wrong, then you have to tear it all down. You have to do it again till you get it right, till it matches the other. But it's not going to exactly match. You're going to have one library of a dependency on these old machines, and you're going to have a new one on the new machine, which is going to break your code. And you see where I'm going with this. So there's a lot of management wrapped into dealing with infrastructure like this. All right. Now, you may be saying, hey, Eric, yeah, but we do containers, right? So we do containers. And containers are a great thing. We have containers, and I work with our container team. We love them, but you still deal with some of the same architectural challenges. So let's take a look at that. I know you do, but what about containers? All right, so let's take this same architecture, and this time we kind of start with that single architecture again, broken out, where our client, our backend, and our database are sitting in a single container, we put that all out there. So not very redundant, so we obviously want to make this more redundant. And we get smart, and we say, you know what, we're going to break that database out. We're going to keep our database separate. So just our client and our backend are sitting in containers, and we're calling back and forth. Excuse me, I'm sorry. Right, so as we break those out. But just like with separate instances for each, with containers, with more redundant container architecture comes more redundant, more infrastructure, more management, more cost. You still have to spread those out, okay? So, and we could talk through the same architecture challenges here, but as you're managing machines on premises, there's a challenge. All right, so moving to the cloud. A lot of people, and obviously this is what I'm all about. I work for AWS, so this is what we talked about. And before I came to AWS, I was a solutions architect at one of our partner companies, and I sat with companies, and I sat down and said, here's how you take what you've got and you move it to the cloud. We did a lot of that, and that's a great move. The cloud offers a lot of tooling to do this. So let's look at these architectures when we move it to the AWS cloud. Okay, this is an infrastructure, right? So one of the really cool things is instantly you'll notice that there's a few more things here. We've got some auto-scaling groups and different things like that. And if you're working with infrastructure, if you're on AWS, hopefully this looks kind of familiar to you. But if you're not, I'll kind of give you a quick overview. Now what our architecture looks like is we've broken it into 2 availability zones. And these are actual physical separated locations on the planet, right? And they're able to speak to each other in very low latency times. And so I can have a load balancer that points to either one of those availability zones. And then I have what's called an auto-scaling group that adds instances as I need it. So the nice thing there is now I've got my management down to one, what we call a golden image. Or I may update all these, but so I use that same image each time. And these are virtual, or these are virtual machines, right? So I'm spinning up virtual machines in instances. So now I'm not having to manage all the hardware. So that's a real win, right? So now I've got this broken out. I've got my client in one layer. I've got my backend in another layer. And then I've also moved to using a managed service for database called Amazon RDS, or Relational Database Service. And this takes a lot of load off me because a lot of my backups happening. I've got data syncing going on, different things like that. So that's a good win, all right? So now let's look at how that looks with containers. So again, we're looking at much the same setup. In this particular instance, we're using Elastic Container Service, right? So we spread that out across some availability zones in case we experience an instance or some downtime on one side, it's going to roll over to the other. So I have resilience, reliability in my architecture, right?
Sorry, I couldn't hear.
So yep, my watch is going off here. Let's just take that off there. All right. So, but while moving to the cloud offers sophisticated automation and tooling to help manage scaling and redundancy, right? That's just the truth. When you move there, that helps a ton. But there's still infrastructure to manage and pay for it. You still manage those EC2 instances. You patch them and you pay for them even when they're not in use. And some workloads look very different. We call it snowflakes, right? Because everyone is different. Some workloads, we say, hey, our application, it's like a banking application, and it only gets hit 8 to 5, Monday through Friday, and then our load just drops off on the weekends. Literally no traffic. Okay, and that auto scaling is great because it knows and it'll bring that in, but you always have at least 2 servers up. So you're always paying. We call that scaling to zero. You do not scale to zero with ECS or EC2 instances using containers or EC2. So you're always going to be paying for some kind of infrastructure, right? So that's another thing to think about. And this is where we start to bring in serverless. So what does that look like with serverless, and how serverless plug into all this, right? So you've kind of explained to me all the architecture and things like that. Well, what is serverless and hello serverless? So let me walk you through what serverless is and how it looks on these architectures that we've just talked about. Excuse me 1 second. All right. So I could put 100 people in a room and say, what is serverless? And I'd probably get 100 different answers. There's lots of different ideas. This is serverless, and then they start splitting hairs and getting into fine line arguments about what it is and what it isn't. Well, for the purposes of our discussion and AWS, this is how we define it. It's got 4 tenets to it. And the first is you have no infrastructure provisioning and no management. So that means you are not going to have to worry about spinning up the instances. You're not going to have to worry about scaling out the instances. You're not going to have to worry about patching, upgrading, all those things. We do that for you, right? The second thing is automatic scaling, okay? And we'll talk a little bit about in the next slides on what that means. But the basic idea is we handle the load, okay? For most parameters, whether you're 10 people hitting it or 3,000 people hitting it, it's going to be the same experience. We handle that load to stretch and shrink as needed. And we scale to zero. Okay, meaning if you don't have anybody hitting your website or invoking your application, you're not paying for any infrastructure as far as the serverless and things like that go. Okay, I know we can talk to you, what storage, things like that. Yes, there's standard AWS for if I'm storing a bunch of data somewhere, but for the Lambda service, you're not paying for that. For the API gateway service, you're not paying for that, right? For SNS, for an SQS, you only use them you only pay for it when you use them. All right. So that takes me to the next one of the pay for value, right? So, that was it in a nutshell. You only pay for what you use. Okay. I use this much storage. I pay for this much storage. I don't have to provision a whole block of storage to store this much, right? I only pay for when my Lambda function is invoked, right? And then the last thing is it's highly available and secure. And so again, in this automatic scaling, and then going further than that, in our infrastructure, I was showing how we have availability zones, A, B, C, D, E, whatever. And then we also have regions, right? The US West 1, EU West 2, something like that. So APAC, all over the place. Right. And so the way Lambda or serverless infrastructure setup is we take advantage automatically of these multiple regions and multiple availability zones within the region. So if I create my Lambda function inside of US West 1, then it's going to automatically be available across multiple zones in that. So if we experience an incident in maybe US West 1 Zone A, then I'm going to call to Zone B to get my function invoked. And it's going to be automatically handled for you. So there's that highly available, right? We also deal with security, right? So with the infrastructure, with Lambda functions and SQS and all the other serverless, we use the identity and access management, right? So that's how you're going to control who has access to your function, things like that. What we're going to control in that security is we know the hardware is isolated, so we isolate it from other people. It's all in protected data centers. We're going to handle all that kind of security so that all you have to deal with is who can invoke your code, but not who can get at it to hack it, something like that. So those are the 4 tenets of serverless. When we look at a service application, and again, this is this idea of, hey, I've never heard of serverless. And so I'm going to explain to you in a nutshell what a general serverless application looks like. There are different ideas on this, but there's basically three parts to it. All right. The first one is what we call the event source, right? With serverless, and this is where some people get hung up. It's like, well, what port do Lambda functions run on, or what IP are they available on? You gotta change that thinking. Lambda functions are only invoked by events. It's an event-driven infrastructure. So that means, like I said, three parts. Something happens, the Lambda function is invoked because that something happened, and the Lambda function does something. All right, so it's very technical. Something happens, we react and do something. It's this event-driven. So the Lambda function is not always up listening for events. It's what we call it's frozen. It's in a frozen state, and when that event happens, then it's triggered or invoked, and then it runs those services. Now, an event source can be, it can be any number of things. It can be a change in data state, like DynamoDB. It could be a request to an endpoint with API gateway. It could be a change in a resource state where you're monitoring some changes to your infrastructure that actually triggers the Lambda function. It could be an IoT button. It could be something said to Alexa. And I'm turning my Alexa off because she's going to try to talk to me here. And so there's all kinds of different things. I mean, really, as far as your mind can think about it, they can trigger Lambda functions, right? A Lambda function itself is just, it's code, right? It could be Node, Python, Java, C#, Go, Ruby, or if you want to use another language, you can use what's called a runtime API. And so you can add your own language to it. We've seen Erlang, we have PHP, we've seen COBOL. All kinds of ideas behind the custom language, right? And then the services, the Lambda function is a bit of code. So whatever you can do in your code today, you can do in your Lambda function, right? Because it's just code being invoked, right? And a Lambda function can run up to 15 minutes. So if you're running some reports or you're doing some long-running things, that can still happen. So that's the idea with serverless, kind of in a nutshell, is you have an event, a Lambda function is triggered, and it does something, right? Something happens, we recognize it, it does something. Very technical. All right, let's jump on. With Lambda services, we see a lot of common use cases. These are not all of them. This is not, this is just a kind of a quick glance, but these are some of the things that we see. We see web applications, static websites, complex web apps. We see backends where folks are writing, hey, we have a mobile app, we're writing a backend for that. Data processing, real-time, MapReduce, batch, all kinds of different things. Chatbots, Lambda functions, or serverless does power Alexa. So when you talk to Alexa, it's usually triggering some type of Lambda function. If you're writing your Alexa skill, if you've gotten into that, you've probably dealt with some Lambda functions or serverless in general. And then one of the common one is also IT automation. Now, I can't see who's out there, and I can't see you raise your hand, but when I'm standing in a room, I'll often ask, how many of y'all are running a cron server where its entire job is, hey, you set up cron tab and you have it, it's doing different things. One of the cool things with the Lambda function is you can do timed-based events. So you can say, hey, every 2 minutes, I want you to invoke this Lambda and do something. And that can handle a lot of IT automation, right? So if something, now I encourage you, if you're looking like I've seen people say, I'm going to have a Lambda check an S3 bucket every 10 minutes for changes. Well, actually, it makes more sense to use the S3 bucket change as an event. So if someone drops a file into an S3 bucket, you can actually trigger Lambda. But there are some things you say, I need to run this report every 10 minutes. IT automation, you can run your policy engines, extend AWS service, infrastructure management, all kinds of things. Primarily for the rest of today, and obviously today, we're talking about web apps and backends and how those work. All right, so serverless and full stack development. Okay, that's obviously the name of this. How does that work? So we're going to go back to our original architecture. We're going to talk about the EC2 instances right now, but we can also apply this to ECS and containers, or just containers in general, or however you're running it. But let's go back to our application. And this is our redundant application where we're managing firewall, we're managing load balancers, we're managing client servers, backend servers, databases, so on. All right. So in this assumption, we're assuming that the client is separate from the backend. Now, if that's not the case, don't worry. I'll cover a little bit of that as well. So think about this as I'm running an infrastructure like this. I want to move it to serverless. What does it look like? Okay. And that's kind of what I'm talking about. So the first thing we're going to do is we're going to get rid of this fleet of client servers. Okay. Now the clients generally just run JavaScript, HTML, CSS, right? All things that, that's what a client is. It runs in the browser, right? So one of the quick, easy wins is to get rid of these 12 servers and host your client in an Amazon Simple Storage Service or an S3 bucket. Now, a lot of folks don't realize that, hey, I can just store or I can host from Amazon S3, right? So what the best way to do that is through a service we call AWS Amplify or AWS Amplify Console. And that's built on top of Amazon S3, which I was just talking about. It also includes Lambda at Edge using CloudFront. What this does is using the power of S3. If you're not familiar with Amazon S3, it is a object storage service, right? So rather than a block storage, object storage. So I can put my entire website in there, all the CSS files, the HTML files, the JavaScript files, everything in there, images, all that. And then I can point my domain at that bucket. Or in Amplify Console, I can configure this all through Amplify Console, set that up, and it gives me Amplify Console actually gives me CI/CD built in, gives me build configurations, featured branch deployments, global availability. It uses again the CDN, which is CloudFront at AWS, and basic password protection. If you want to do like beta, hey, if you want to see the beta site, you have to use this password, that kind of thing. What this does is this immediately gets rid of all these servers that you're paying for to have your client running, right? So you should see real quick is, okay, that's a quick thing. Your backend doesn't have to change. You can do this first and just say, okay, I'm going to put this over there, get it all working, and then I'm going to repoint my DNS at my client, and you could still call the backend. So that's step number one, right? So at this point, our proxy firewall now points directly at the backend. Okay, so our client can now call this firewall, and it calls directly to the backend. So the next thing we want to do is we want to get rid of these load balancers, right? For serverless, we don't need to use multiple services that we're running as load balancers. We can use something called Amazon API Gateway. Now, as an Amazon API Gateway, it handles load balancing and redundancy built in, right? It's already going to rotate between servers as needed. It's going to, you can point at, so I can use Amazon Gateway and point at what we call our elastic load balancing service that will spread across machines. With the Amazon API Gateway, you're automatically going to get REST, WebSocket built in. You're going to get throttling. You're going to get caching. There's all kinds of things you can that sometimes you handle in your code that you can offload to Amazon API Gateway. So that way you're not managing a bunch of stuff. And one of the key things about serverless, or one of the things about modern applications, are how much can we pull out of our code? How much can we reduce from our code by using managed services? And that's kind of a mantra with serverless itself, is using what's built into the managed services versus reinventing that wheel over and over with our code, right? So you get this idea of Amazon API Gateway. And I do a lot of talking about Amazon API Gateway, and I'll share a link at the end here, where I have a session that I did at reInvent last year called I Didn't Know Amazon API Gateway Did That. And it really talks through things like form validation. If I'm submitting data, I can validate it at Amazon API Gateway before it ever hits my backend servers. If it doesn't have all the right data, I can kick it out. I can do, again, the throttling, the caching. And the way we built Amazon API Gateway is you can bolt on different things. Like I can bolt on a web application firewall or a WAF. If you've never dealt with a WAF, it used to be, man, that was a complex system. But we've made it pretty easy. You can set it up right in the console, and it just bolts right onto your Amazon API gateway, and you have a WAF for extra security. You can have your SSL offloading. You don't have to handle your SSL at your load balancers or your servers itself. You can handle it right at Amazon API gateway, including with custom domains. You can do API user key and throttling. And I can keep reading and showing you things, but you get the idea. There's a lot of things you can do there. Okay. And the fun thing about this is the pricing, and I haven't talked too much about the pricing of serverless. Let's take a moment to talk about that. For Amazon API Gateway, first of all, it's in the free tiers service. So your first 12 months, you get 1 million REST API calls or 1 million HTTP API calls. We have two different versions of our API Gateway, and you pay as you go. So it's either $1 or $350 for your first 300 million calls. If you use our new HTTP API service, it's $1 for your first 300 million calls. So pricing is good. Pricing is very inexpensive versus running a bunch of load balancers, right? All right, so now that we've done that, so now all we've got left in our architecture is we've got this Amazon API Gateway. We've got our S3 buckets running our client. And we have, again, you're looking at all our servers. So let's see what we can do about those for our backend servers. Well, this is where AWS Lambda functions come in, right? So AWS Lambda, we can pull out these backend servers and we can put it in 1, 2, 3, or 5 different Lambda functions, depending on how you do that. And I'll talk about how you break that down in a little bit. All right. So with Lambda, you get your first 1 million. And Lambda is also in the free tier, but it's a little different. You get your first 1 million events per month free forever. That's not just for the first year. Okay. Again, I already talked about you can run your custom runtimes and language supported. It's triggered by many internal and external events. And you can have. So this is where I talked about dealing with how your load's going to work. Let's talk about that for a second. We've got several blog posts and articles about this on our blog as well to understand. So I encourage you to read that. But when we talk about Lambda functions, we have a concurrency, and that means how many Lambda functions can be invoked at the same time. So the way Lambda functions work is regardless of what's invoking it. let's use an API endpoint. I'm so sorry. Let's use an API endpoint. So I have an API gateway in front of a Lambda function, and I've got my Lambda function here. Let's say I have 10 people hit, okay? And they hit after another. They're not all at the same time. They hit about every 10 seconds. Well, if it takes less than 10 seconds to run my code, then my Lambda function is going to invoke, and it's going to go back to a frozen state. And then the next person is going to invoke that same Lambda. It's going to come back to a frozen state, and so on. All right. So I've only got one Lambda, so I have concurrency of 1 at the moment. But let's say I have 50 people hit exactly the same time, literally at the exact same second. What the Lambda service will do is it will spin up 50 Lambda functions to handle that load. Right. So that's concurrent. All right. So it's a point in time. So Lambda can handle up to 1,000, or your account can handle up to 1,000 concurrent invocations at a time. So if you had 1,000 people all of a sudden hit at the exact same time, exact same millisecond, it would handle all those. And it is a soft limit that can be raised if you need it, right? But generally, more what that looks like is it's staggered a little bit. So you'll have several Lambdas up, 500 Lambdas up and alternating, and they stay warm. We call it warm. They stay warm for anywhere between 5 to 15 minutes, depending on some different variables, and then they go back to, and then they're reaped or cleaned up. If there's no Lambda function available at the time, then the Lambda service will spin up a new one. It's called a cold start, and it's very quick. So there you go. Hopefully that makes sense on how that works. All right, so we've taken out our backend. We've put AWS Lambda in there. The last thing we need to worry about is our database. There's multiple database options at AWS. You can see a lot of them here. I probably need to update this slide. There's always great work going on with our database service. But when we're dealing with web services, this is generally where we live. Not always, but generally, either Amazon Aurora Serverless, Amazon Document DB, Amazon DynamoDB, which is where I generally live. If you're not familiar with DynamoDB, it's a very, very, very high input-output database, and it's a key value And it's more than just key value. It stores, obviously, it's a NoSQL database. If you've never heard, we have a little company called Amazon.com that gets really busy at Christmas time. And a lot of what's happened there is run on DynamoDB. So I'll tell you the kind of power and speed it can handle. And then we also have Amazon RDS, which handles relational database service. Both Amazon Aurora and Amazon RDS are relational. Amazon DocumentDB and DynamoDB are NoSQL. Amazon DocumentDB, if you're a MongoDB user, we have MongoDB compatibility with that. So cloud version of that. And I break that down a little bit here. Again, relational databases versus NoSQL databases. Your NoSQL databases, they're all built to be redundant. They're all built to be syncing. But the way the NoSQL databases work with DynamoDB, DocumentDB, and actually Aurora Serverless specifically, they're highly redundant in the fact that when you write data to these, they've separated the storage from the compute. And when you write data, there's 6 copies of your data automatically written in 3 different availability zones, 2 per each. So, and then the system handles making sure that data is in sync. But highly, there's not enough highlies in this. Highly available and highly durable, I guess is the word I'm looking for. Your data is very durable because it's multiple places. So and then RDS handles, this is where you can use SQL or Oracle or Postgres or MySQL. Those also handles the syncing with that as well. So primary and secondary database service. All right, so let's put it all together. I've been talking a lot about changing things out. I want to show you what architectures look like purely serverless now, kind of taking our application and going purely serverless. Now, remember, we had this architecture that had all these servers, but that same exact application would look something like this. Okay, and we're going to add some components to it in just a minute, but this is our backend. Okay, this is a basic website backend, and your user is going to hit your Amazon API gateway. It's going to hit the Lambda function for the backend. That Lambda function is going to use either a DynamoDB or, all the different options I was talking about. Hey, what's up?
Okay, Eric, that's a question. So since you wanted to answer it on the fly, so Arjun here has a question. Can we say that we can use API gateway as a service versus API gateway as a separate complete technology?
Can we say this, that we can? Yeah, it's interesting. I'm not sure where I would draw the line there. It is a service, right? API gateway is a service, and it's a managed service, right? So I would probably put it in the managed service or service label. Because you don't have to bring up this architecture or anything to support it. I would literally, and I'll talk about SAM in a little bit and some of the frameworks. But from a very beginner standpoint, I can go into the AWS console, I can go to API gateway, and I can click create an API gateway, and I add another, and underneath that, you're already going to have its API gateway is going to sit on top of a bunch of servers that are spread across many availability zones, things like that. So there's a fine line in this. You can see me in my head going, well, but as far as technology, because of the managed services, it used to be, okay, hey, we have this managed services, it's going to be API gateway, but we rolled so much into it to allow you to roll so much out of it that it is a technology in itself, as far as I'm going to handle throttling, I'm going to handle caching, I'm going to handle authentication, right? So I don't have to do authentication in my service anymore. I can do JWT, OpenID, I can use custom authorizers, and so there's some technology built in there as well. I don't think I answered your question exactly, but hopefully that helps you kind of get an idea.
Hope it helps, Arjun. If it isn't clear, you can again ask another question. We have Eric for some time here. Thanks. All yours, Eric. I'm going off.
All right. All righty. So here we are sitting here. And with my Lambda function, I can either connect to, I'm going to do Amazon Aurora, or I'm going to do Amazon DynamoDB table. These are just the example ones that we're doing here. And if I do use Amazon Aurora, which is an RDS or SQL database, I'm going to use a service we have called Amazon RDS Proxy. Okay, and the reason I'm going to do that is as we talked about, Lambdas come up, they do their work, and they go away. Lambda functions, right? So they're very ephemeral, right? They come up and they go away. And every time you make the call, it's not guaranteed that you're going to hit the same Lambda function. It could be a different machine in a different zone, something like that. So sometimes that makes some complication in dealing with SQL connections. So we've got you covered. What we did is we built what we call RDS proxy. An RDS proxy will maintain a pool of connections for you to talk to one of the database services, Amazon Aurora Serverless, as an example. And then your Lambda function will just talk to we'll call Amazon RDS proxy, and you're still just use the IAM or identity and access management permissions. You don't have to put your passwords and your usernames into your Lambda function code. It's all stored at the proxy, far away from the client. So again, I can do either option here. Now, earlier I said, if your client is built in with your backend, you can render that right out of Lambda functions. So you say, Eric, my client and backend are tightly coupled. The first thing I would tell you is I'd try to separate those if you can. That just in modern application development, that helps a lot. It gives you a lot more freedom. But man, I get it. We all deal with legacy systems. Yeah, that sounds great, but this is what I have. So what we can do is you can render that HTML out from Lambda function using, if you're using Razor or any kind of templating engine, much like you would a service. All right, so I talked about how the pools are shared with Amazon RDS proxy here, and then here's the fun thing. Okay, so you're looking at this, you go, man, that's one Lambda function in one database. So that's a lot less than what I had with my architecture. Is it going to handle the load? Well, like I said, all serverless services scale automatically as needed to handle client requests, right? Up to 1,000 concurrent requests on Lambda. Again, that can be raised. It's a soft limit. Up to 10,000 requests per second on Amazon API Gateway. Right, so you can handle this massive amount. Now that's not per Amazon API Gateway; that's shared per region. So so clue there is it's per region per account. So if I'm going to have multiple applications, I have application for company A and application for company B. Those should live in separate accounts so they don't share the same limit bucket. Right, just a little pro tip there. All right, so your application is going to scale as needed without you having to put a lot of machines in. And when there's no traffic coming, it's going to scale all the way back down to zero. Right, so it does scale down to zero. Now, let's throw our client in. Okay, so your client application, as I explained in the very beginning, your client application is hosted serverlessly and scales to meet load as well through AWS Amplify. Which is also, which is on top of Amazon S3. For user management and authentication, you can use Amazon Cognito, right? Now, you don't have to use Cognito. You can use one of the other, you could use an Auth0 if you like that. You can write your own if you want. You can use, an Active Directory to log in, things like that. This is just a simple website that uses Cognito. And how that works is you build you manage your user pool on Amazon Cognito, and you can create federated IDs there or federated logins through Facebook, some of the different federated providers. And then when your user calls to Amazon API Gateway, if they're not authenticated, they can be redirected to an authentication service wherever you have it. But then when they get that token, Amazon API Gateway using an authorizer can verify that token, right? So if you're using like a JWT token, it can grab it has the issuer address and it can verify that. And it caches, some of it's cached, so it's very quick, some of it's not, based on how the security needs to work. So how this would work is your user calls your client in AWS Amplify console, and they get everything downloaded to their browser, right? So that's their client. And then their client has a login and then calls for data against their backend. When their backend hits Amazon API Gateway, it goes to a Lambda function to get data, pulling from DynamoDB or any other number of services. Now, I said that's one Lambda function, but when you build out service architectures, much like when you build infrastructure on premises or anywhere else, you want to think logically, how do I separate this, or what we call separation of concerns, right? So you don't want one Lambda function doing all your work. It generates reports, it logs people in, you want to break it down logically. So let's say we have one that handles users, right? We get maybe a user profile. We have another one that does orders, okay? So we submit an order. And we have another one that does reports. And these are very small chunks of code for each Lambda function. And each Lambda function has a single responsibility, right? So that's really breaking it down, separating it out, and keeping it manageable to build this out. And then you can get into, now that's everything we've seen so far is what we call synchronous architecture. In fact, let's go back for a minute. Synchronously, if I hit Amazon API Gateway, it's going to call Lambda function. It's going to do whatever work, and it's going to respond to me. Okay, now I can do that asynchronously as well, but generally when we're making API calls, they're synchronous, right? So what if I want to do some work after the fact that the user doesn't need to watch the spinning wheel for? And that's really, I do a whole session on this on thinking asynchronously. The less time a user has to wait, the more your site looks active and fast, right? So, I mean, in today's world, if a user sits on a spinning wheel longer than 5 to 10 seconds, that website's broken and I'm gone, right? So something to think about. So if I need to do some work after the fact, I can start doing some other things. So with Amazon Dynamo, this is just an example. With the Amazon DynamoDB, we have a thing called streams. And so when you insert stuff into Amazon DynamoDB, there's a log that comes out the backside called a stream that you can trigger a Lambda function with. So I invoke a Lambda function, and maybe it says, hey, for every order placed, I'm going to put it on an Amazon Event Bridge bus. And this is a bus for communicating between different services. And that bus has some rules on it that will trigger more actions. One may update another database. One may, there's all kinds of things, print out some records. I mean, again, it's only limited by your imagination. So when you're building serverless microservice websites like this, you think synchronously, what does the customer need right there and then? And you think asynchronously, what can I do after the fact, right? So you get this idea of how this serverless architecture is getting built. And when we get into next week and the week after, we'll get a little more complex in looking at how these interact with each other. All right, so here's the best part, okay? I've done all that, and I have no server management required. That's serverless in a nutshell, guys. When you're building this kind of stuff out, you're not dealing with all the infrastructure. You're just dealing with your code and managed services, right? All right, so where do I start? And this will be a high level. We're going to get more into it later. But just if you kind of want to get, you want to look at this and go, okay, there's a lot here. Where can I get started? You can always start in the AWS Amazon or the console, and you can create a Lambda. But really, when you want to scale out and you want to start building applications, you want to start with a framework. And I can't say it enough times. Start with a framework. Start with a framework. Start with a framework. There's a guy named his name just jumped up. Boy, that I was at Alex. Alex he worked for Serverless.com, which is one of our partner frameworks I'll mention in a minute. And Alex Debris, there it is. Boy, it's early here and I'm old. So we were sitting together, we were having dinner, and there was a gentleman sitting across from us, and he was talking about building a service application. And the application sounded great, it sounded really cool what he was building. And he said, and both of us said, because I'm a SAM guy, and I'll tell you what SAM is in just a minute. It's one of the frameworks at AWS. And Alex is a Serverless.com, and we're partners, but in some way we're competitors because they do the same thing. The Serverless.com is awesome. It's called the Serverless Framework. SAM is awesome. My thing is use one of them. I don't care which one you use it. But we're talking to this gentleman. We said, how are you managing? You've got all these Lambda functions. How are you managing all these? Oh, I write my own scripts. I do it all myself. And we both just kind of looked at each other and said, oh man, you're reinventing the wheel, and you're incurring a lot of extra heavy lifting that you don't need to do, right? Starting with a framework, a lot of this will be done with you. And I'm going to be demonstrating SAM in the next next session or so on what this means. Or if you want to get a jump start on Tuesday at our serverless office hours, I know it's 10 a.m. Pacific time, which I think is like really late there. I can't even do the math. It's going to be later there. It's like 9 or 10 there, but I'll be showing how to build image or Lambda functions with container images support with SAM and showing how that framework works. But start with a framework. So let me talk about SAM for just a minute. SAM is the serverless application model. You see the squirrel a lot. That's our mascot. The serverless application model comes in two parts. First, there's the model itself, and this is if you're familiar with CloudFormation, then you recognize SAM, the model. It is shorthand syntax to express resources and event source mappings, and it provides as infrastructure as code. So you want to get out of the idea of I'm going to point and click to create all my services and serverless architectures and link it all together. Instead, you want to store it as infrastructure as code. You want to store it in your YAML templates or your JSON templates, and that's what the SAM model does. The second thing we have is the SAM CLI, and this provides tooling for local development, debugging, build, packaging, and deployment, and all those. And so from my desktop or from Cloud9 or whatever ID you want to do, as long as you have a terminal, I can say SAM init, and it'll create a new serverless template or framework for me to build. So it'll have just basically a scaffolding of a serverless application, hello world. And then I could start adding more resources as I need it. And then the other one is the AWS CDK. This is coming on strong as well. CDK allows you developers to define cloud infrastructure using familiar programming languages, right? So you use TypeScript, Python, .NET, Java. The idea here is the CDK, AWS CDK and AWS SAM do a lot of the same thing. There's a ton of overlap. They just do it differently. And as developers, we do things differently. Some folks like the declaration of SAM. SAM is a declarative, here's my template, this is what you build. CDK is through code. And so, hey, I want to use TypeScript to declare these rather than JSON. So it is preferential. We do things differently. There's like, well, I use CDK or, well, I use AWS SAM. Man, either work. Use what works for you. They play nicely together, and they're getting to where they play much. The same CLI does a lot of local development, and we're working to make it play nicer with the AWS CDK. So we don't see them as competitors. We see them as complementary and, again, preferential. The last one we have is the AWS Amplify, which might be a little confusing because I was talking about the AWS Amplify console earlier. This is a little different. This is a framework that you actually download and install it, and then you can generate back-end equipment. So this really comes at the angle of I'm a front-end developer, and I want to manage my back-end as well. You can do APIs through AppSync or through API Gateway. It has analytics built in, a lot of things built in. It's a great framework. So again, depending on your preference, I encourage you to check this out. It also builds out serverless. You can see, I'm going to go back for a second. You see here the aws.amazon.com/serverless/SAM. I didn't realize I didn't do a short link on that. But if you want to grab a snapshot of that, or this is in the video. But then here, s12d.com/CDK will take you to CDK documentation, and then s12d.com/amplify. All right, and so that we have some frameworks, third party, as the one I talked about here, serverless framework. Again, fabulous. Sparta, Claudia, Apex, different ones that you can look at. Again, I'm a SAM I'm a SAM person, but it's preference. Just use a framework. I encourage that. Now, we have a few minutes, so I want to go back here. You see it here where I'm talking to s12d.com. This gives you a good idea of serverless. This is a URL shortener that we built. We use internally here at AWS, specifically our ServerlessDays team. And s12d.com is built entirely serverless. In fact, and this is kind of 400 level, we've been talking a little bit, but it uses just managed service. There isn't even any code in this. We use the power of API Gateway itself and the ability to transform requests with an API Gateway. and we use CloudFront, and it builds this URL shortener. It has a front end built-in view or in JavaScript, and then it has this back end. And so we can quickly add any short links and generate your QR code and things like that. But it's entirely serverless. It is globally delivered through CloudFront or CDN, and it is crazy fast. So if you go to s12d.com/CDK, it should hit pretty fast. It's just an idea of we use what we teach. So everything we build is serverless. In fact, here this year, Amazon announced that over 50% of their internal services are being built on serverless as well. So if you're wondering if serverless is really a thing, Amazon believes so, and Amazon's a pretty good sized company. All right, so that wraps us up for this session. In the next session, we're going to be talking about getting started with serverless. And this is going to look a little different than what it looks like in full stack. We're actually going to climb in and look at some of the settings, some of the configuration. We're going to get deeper into concurrency. We're going to get deeper into what are the other services that we can use to start wiring up serverless applications. If you want to get a jump start, I encourage you to check out our website. This is managed by the AWS ServerlessDays, our developer advocacy team. And serverlesslane.com. We host everything we do there. And with that, I'll remind you again, my name is Eric Johnson. You can find me on EDJ Geek on Twitter. And again, I'm not always the fastest, but I answer as many questions as I can. And if I don't know the answer, I can often get you to the person who does. And with that, serverless for everyone. I'm going to turn it back over to you.
Thanks, Eric. It was an amazing session. And to be honest, I'm primarily from Azure. The AWS is something new for me, and I learned a lot of things.
Good.
So there were a few questions over here.
All right.
So there's one from Jones. So what would be better, API Gateway or AWS AppSync?
So better is a tough thing to classify, and boy, you just have made all the answers. That's a it depends question. It depends on what you're trying to do, right? So AppSync is going to you get some power there on combining, and it's more about talking directly to the databases and building these different calls, and you can join across different data sources. Whereas API Gateway is going to handle a lot of it's more the front door idea, right? It is the throttling, the WAF extra security, the caching, the different things like that. So it kind of depends on how you want to approach that. So if you build with Amplify, it tends to go the AWS AppSync, kind of that front end reaching into the back and doing the API gateway that way. Although you can do it API. If you build directly SAM, it's this is more for like, hey, we're building a large application. We've separated our front end and our back end, and we want different clients to be able to call. Then I would probably go with API Gateway.
Okay, I hope it answers Jones. So let's wait for some time for a few more questions. In the meanwhile, I have a question for you.
Yeah.
So, SAM is exciting. I'm pretty much sure that I'll be using it sometime around this weekend. So, I have been using Azure Function for quite some time. So SAM model and SAM CLI. So do I need SAM model to, build in Lambda in my, workstation? You
don't need it, but you want it. If that answers your question. Yeah. So what SAM does, and again, I go back to this, use a framework, right? And the framework, what the framework's going to do is, so let me give you an example, and this is kind of a precursor to what we'll see next week. But with SAM, so if I use, so let's go step back. You want to use infrastructure as code. All right. And what does that mean? That means instead of me pointing and clicking and building, so let's say I build a serverless app in the console. I create an API gateway. I click it, I link it to the Lambda. I can build a serverless app in the console, right? And they can make it work and it'll be great. But then someone comes and says, that's great. We want to use the same thing. Build it in my account. Well, then you got to remember all the point and clicks and everything, right? But if you do it as code, infrastructure as code, and it's stored in a YAML or JSON template or CDK code template, then you can say, oh, yeah, no problem. Here's the template. Run SAM deploy. You're done, right? So that's a 5-hour versus 2-minute, So that's the argument for infrastructure as code itself. right? Our primary tool at AWS for infrastructure as code is called CloudFormation, right? And so almost every service we have can be deployed with CloudFormation, configured with CloudFormation, updated and versioned, because you can version that. So what SAM and CDK and Amplify to a degree do is they give you a way to generate CloudFormation, right? So with SAM, if I want to do a Lambda function, I can take, and in 20 lines of code, and again, I'll show this as an example next week, 20 lines of code, right, will create an Amazon API gateway endpoint in front of it. It will create the Lambda function itself with the permissions I need. We always use least permissions or least privilege permissions. And it'll create a DynamoDB database that the Lambda function can talk to. So you're talking, plus all the roles and everything. So you're talking, in CloudFormation, that's about 190 lines. Right? And you're welcome to write those 190 lines. But with SAM, if I can do them in 20 lines and it expands to that, that makes life easier. Same with CDK. So hopefully that helps you out. But again, not required, but heavily encouraged.
That's super exciting, Eric. So yeah, there was one more question. If I just installed SAM CLI and, can I build my applications? Can I build a Lambda function in my workstation and simulate it? Like, local development thing?
You can. So with SAM CLI, we emulate locally, invoking the Lambda function itself, so a direct invoke. We also can emulate invoking the Lambda function through an API gateway, either HTTP API or REST API. So you can emulate those. Now, we also have it set up, so that as you're testing, and this is what we encourage, I've seen a lot of people that are building a local version of S3 or a local version of Simple Queue Service, which is a or SQS, or SNS, which is PubSub, right? And the problem with that, your local, at AWS ourselves, we offer DynamoDB locally. And it's great. It's great for mocking, getting an idea. But when you get into testing, the problem with that is we end up working and wrestling so much with getting the container, the Docker network to talk to each other, and this, and then your code doesn't work, and then you're wondering, is it my local emulator? Is it my code? You really battle. So the way we recommend is from a local Lambda function, which that's what you're invoking, that's what you're iterating against. From a local Lambda function, you can talk to the rest of it. So I can talk to DynamoDB in the cloud from my local Lambda function. So I can actually spin up a local version of API Gateway that will have, if I have 7 Lambda functions that all are different endpoints on it, and then I can point my local client to that local instantiation, and it'll call out and work against cloud services. So you can test the services, but locally, but not having to emulate it all locally. Hopefully that made sense.
That's great. That answers well. So, this one more is actually from the architecture diagram that you had shown in the previous slides.
Sure.
So, there were so many Lambdas, Lambdas are basically a unit of work, we can say like that. So
yeah.
Managing so many Lambda units is going to be really difficult. So how do we do that? How do you recommend to do it?
So what we do, there's all kinds of not battles, but conversations, heated conversations around mono repos and all that kind of stuff. Here's how I approach it. Here's how we recommend. When you're looking at an application, we like to break it down logically by, what is being called, what's being done. So like if I have, remember I talked about synchronous and asynchronous. Let's just talk about endpoints for a moment. If I have a logical break in endpoints, here's a service, right? Here's a service built with maybe 4 Lambdas that handles reporting. Here's update report, download report, stuff like that. That's a logical application. Right. And the way we architect is we believe in very, very loosely coupled, right? So or decoupled is the word. It's so loose that it's decoupled. Decoupling applications so that one Lambda function isn't even aware of another Lambda function. If they need to talk to each other, we talk to them through queuing, through SNS, which is like a pub sub, or queuing through SQS, right? so that if we mess up code or something goes down, it doesn't take the whole app down. So we break these applications apart logically, and so that's my user service. So that's one SAM. So I'm gonna talk SAM for a minute. That's one SAM template. It has the 4 or 7 Lambda functions in it that are required to build that with the API gateway in front of that. And then if I have another service, and that'll have its own, maybe API gateway, and then I can do an umbrella. There's different ways of approaching this. I can use CloudFront endpoint to these, or I can use an umbrella API gateway that points to these different ones as well. So that's maybe in yet another SAM template. So it's all about logically breaking apart. And this isn't unique to serverless. This is, if you're building large applications, you really want to break those down and have them in consumable chunks, right? That's just good practice. So the same thing with serverless. So you think of Lambda functions as independent pieces of code that just do one thing, and that one thing really well. So that's single responsibility. And then generally, to finish this thought, one SAM application is one template, all the code for it, all the dependencies for it, and then that's a repository. So that would be one GitHub repo, and that would have its own deployment cycle and things like that. And because it's living behind an API gateway, as long as that contract stays the same, right, we're okay. Nobody cares what happens behind it as long as I still get the answer from it. So there you go.
Okay, since we did talk about deployment, this one question from Jones. How would we do a CI/CD process with SAM?
So and I'm going to ask you to post a link for me. It's s12d.com.
Okay.
I'm going to answer the question, but I'm going to give you more information on this too. s12d.com/CI/CD. And there's a ton, and there's 6 or 7 videos on CI/CD with serverless, some by me, some by some of our other DAs. So that'll give you a lot more than what I could give you here. But just like any other architecture, with Lambda functions, API gateway has canary releases, at least the REST version. So if I'm making configuration changes in API gateway, I can set it up so that it does 10% for 5 minutes or something like that. So I have a canary release, so I can automate that. Same with Lambda functions. You can stagger the release, right? So that's not really CI/CD. That's just more talking about deploying them safely. It's what we call safe deploys. As far as CI/CD, because you're versioning, because your entire, the infrastructure and code are all kind of together in templates, right? It's all just files, stuff like that. You can version them in GitHub or Code Commit or GitLab or wherever. And then when I commit my changes, just like non-service architectures, I can have build pipelines. And the only difference here is, rather than me having internally, or not internally, but at AWS, we have a code suite, and to deploy code to instances like EC2, things like that, we have a thing called code deploy, and it actually will take instances out of rotation, update the code, put them back in, and you can run tests and things like that. The main difference here is serverless doesn't use code deploy, it uses CloudFormation to deploy your code, because it's just changing architecture. Hey, we need another Lambda function. Hey, we need another SQS, things like that. So you can set up an automated pipeline triggered by GitHub, some type of Git repo that runs the pipeline, and you can have, using code build or Jenkins or some external, you can run tests against your Lambda functions, and you can exit out if they fail or continue on if they work. And then you can move into the deployment. And then you can, really cool thing with Lambda is at the actual function level is you can do pre-launch tests and post-launch tests. And if either fail, the entire stack will roll back. And I talk about that in that link that I gave there. So there's a lot more to that, but hopefully that kind of whets your appetite.
Hope it answers John's, but okay, Eric, the link is not working, so it would be great if you can drop it in the comment. I try to reach it out before posting it.
Yeah. I'm gonna put it in the private content real quick here. S12.
Sure, that would be great.
CI/CD. I know this works, but now I'm hoping it works.
Okay.
Here, I'll try it real quick.
Sure.
So, yeah, that should work, because Well, that's a horrible thing if it's not working. CD. It works.
Okay. Okay,
Yeah.
great.
Yeah.
Maybe there was
Yeah.
a typo
Yeah.
from my end.
Yeah. Just grab that copy. That works, and it's a whole playlist on CI/CD. So.
It's there on the screen, guys. You can see it, as well as it's mentioned in the comment section. You can pick it up from there and just go there and learn more about it. So final question from my end, Eric. Can I create a custom event to trigger my Lambda function?
A custom event to trigger? Yeah. So there are different approaches. Any one of the services. So, well, give me an example. I mean, yes, you can do a lot and create custom things, but give me an example of what you're thinking.
Probably, some changes happen in my RDS for, SQL Server, something like that.
Yeah.
This particular event is not right now, available for Lambda. It doesn't come out of the box. So I wanted to write and, kind of a trigger to enable, Lambda function to work when this particular event happens. Can I register this particular events?
Yes. So what you can do. So the example you have, there's a blog. Someone just did a blog on this about 2 months ago on. You're talking to a guy who's not a SQL guy at all. I can barely spell SQL. So, yeah, you can run. So there's a couple of ways you can do this. You can use a Lambda function to look for changes. You can use, if your SQL Server or MySQL, something like that, has any kind of eventing like, hey, every hour we're going to run this report and drop it in an S3 bucket, right? So if you do that, then that S3 bucket can trigger the Lambda function. So what you're able to do is you're able to say, I'm going to get the event I want, I'm going to get it into one of the supported, an S3 bucket change, a DynamoDB change, or I'm going to directly invoke Lambda through either an API call or the actual. So Lambda is invoked through an internal API all the time, and the SDKs can invoke that directly. So if you have some kind of code that's looking at that, you can always call the Lambda function. So yeah, there's usually a way to do it. If you can't figure it out, let me know.
Sure, I'll get back to you if I can't figure it out by my own.
Yeah. Hit me up, and there is a blog. I'll have to find it. That we posted on how to do it out of. I believe it was MySQL.
Perfect. So let's see if we have any more questions for 1-2 more minutes. So
I posted one more link there if you want to do this. I do a series called, because obviously it sounds like there's a lot of interest in SAM itself, which makes me happy. I did a series last year called Sessions with SAM. There's about 24 episodes, half hour each. And this will take you there, and it is just talking. It gets more complex, and in setting up a lot of things, you're just asking, how do I get, what do the templates look like, and what are examples of, all kinds of things. How do I use EventBridge? How do I use SQS? How do I use SNS? How do I build just simple authentication with HTTP with an API? So I do a lot of those examples using SAM, and I show how to deploy. So, and it's actual code, not a screenshot or not a PowerPoint.
The link is there on the screen, guys, so you can take it up from there, or it's also there in the comment section. So we can wait for 1 more minute. If you have any questions, you can just shoot it out at Eric, and he's quite open to answer them.
Yeah, and if you don't get it here again, hit me on. I encourage you to follow me on Twitter at EDJGeek, and glad to try to answer them there as well.
Sure. I guess that's all, Eric. So thank you for being an amazing speaker and, joining us for hosting the session. And I'd like to thank James for, helping me get in connection with you.
James is way smarter than me, just so you know. He's a smart guy. So, and we'll be back in 2 weeks, right?
Right. Yeah, we'll be back in 2 weeks. But just now we got a question from Bill. So
okay,
should we take it up?
Yeah. Can API Gateway respond to a webhook and put data into DynamoDB without Lambda? Oh, Bill. I know you, Bill. Yes, you know it can. And I have an example out there where I build the URL shortener, in fact, that I was showing you, that s12d.com, that actually does interact with DynamoDB directly without a Lambda function. And I'm going to grab a link real quick here. And it's not going to be a shortened one. I'm sorry. But hang on a sec. And this is an example of how to do it. It might be a short one. Oh, yeah, it is. All right, so I'm going to give you another link real quick here. Slip. This is my old shortener, but it's still up. This uses the same exact shortener code. So again, I have it all built in SAM. So if you want to deploy your own URL shortener, you're welcome to use this. Slip.link/shorty. That will take you to that. This is an example of what I call lambda-less coding, and it's really, again, it goes back to the magic of serverless, of chaining together managed services and removing as much code as you can. I do a little bit of logic at the API gateway level, but not a lot, just some transformations, and it's a highly secure, highly performant infrastructure.
Perfect. I think it answers. Bill said, "Cool, thank you." So that's some appreciation. Great session, Eric, and we'd love to have you back. And people do subscribe to our channel and like our Twitter page. This is the Twitter handle over here, ServerlessDays B. So that's the best way to connect. And if you want to become a part of the whole thing, if you want to become a part of the community, feel free to reach out. You can just drop a message in the Twitter handle, and we are open to take you in. We are looking out for volunteers to organize the events. So Eric, I think you are also an organizer of one of the ServerlessDays chapter. So
I'm not. We talked. Surprise! I've talked about trying to do one in Colorado. That's where I'm at in northern Colorado, which is getting ready to snow. But I'm not. But I speak at a lot of them. And I love doing the ServerlessDays. So yeah, I'm pretty heavily involved with them, but I don't organize one yet.
So if you do, you can just speak out over here. Until then, people just subscribe our channel to stay updated. And Eric will be looking out for your next session 2 weeks from now.
Sounds good.
Thank you. Then let's end the broadcast, and thank you people for joining in on a weekend. Bye. Take care. Stay safe.
Bye all. Thank you.